A complex rational expression is a rational expression that has a rational expression in the numerator and a rational expression in the denominator. What does that mean? The numerator's got a numerator, and the numerator has a denominator, and the denominator has a numerator, and the denominator has a denominator. Yeah, that's so complex. What we're going to be doing is we're going to be talking about one of the traditional methods of simplifying these rational expressions. Here we have a rational expression. Okay, and one of the traditional methods is to multiply the numerator and the denominator by the common denominator. So you're going to factor first. Okay, so I can't factor either one of those terms in my numerator. 3 over x plus 2, minus 3 over x minus 2, woo, that's all over 5 divided by, that's screaming difference of squares, x plus 2, x minus 2. And now I ask you, what would a common denominator of all the denominators be if you had one? Yeah, I do see that my common denominator is gonna be x plus 2, x minus 2. Okay, so it's my intention to multiply numerator and denominator by that common denominator. Okay, so then here we go. I multiply this numerator by x plus 2, x minus 2. Oh, but what you do to the numerator, you must also do to the denominator. Yeah, essentially we're multiplying by 1. X plus 2, x minus 2. Yeah, see how x plus 2, x minus 2 over x plus 2, x minus 2, that thing's 1? Yeah, we're essentially multiplying by 1. And then this goes, this goes, this goes. And similarly down here. Alright, so now to save time on this little board, what I do want to do is I want to check out what happens when I distribute in here. Okay, when I distribute in here, I have x plus 2, x minus 2 times 3 over x plus 2. And what are you going to see every single time? Every single time you're going to see the common factor is going to end up reducing. So in order to save board room, I'm taking it right on down here. Yeah. And here I see I'm going to have 3 times x minus 2. Yeah. Okay. Why? Because the x plus 2 is going to cancel or reduce or fight with the x plus 2. Okay, so then you have x minus 2. In essence, I'm taking this numerator and I'm multiplying it by whatever its denominator is missing that the common denominator has. And then I'm subtracting off 3 times. When I distribute in there, that reduction is going to happen once again. So I'm going to take that numerator and multiply it by whatever its denominator is missing that the common denominator has. So I multiply that by x plus 2. Yeah. And then down there in that denominator, oh boy, check out the entire annihilation of this denominator. Oh boy. Bam, bam. Looks like the x plus 2 and the x minus 2 are both going to reduce. So then I'm left with an all over 5 situation. Yeah. So then I'm going to go and I'm going to clean up that numerator. Why? We're trying to simplify this complex rational expression. It had a fraction in the numerator, 2 of them, and a fraction in the denominator. Yeah. So then I'm going to keep on keeping on. 3x minus 6. Okay. And then, and then that's a minus 3x minus 6 divided by 5. Oh wait, it appears to me that we have additive inverses. Yeah, the number that when added to the number, the sum is none. Oh, and what it all comes down to, it looks like this is going to be a minus 12 over 5. Very nice. What does that mean? It doesn't matter which x you picked, as long as it wasn't plus or minus 2. In the original expression, if you were to evaluate that expression, it would always come out to minus 12 fifths. A box and a flag.